Don't just play Genesis classics on your MiSTer, feel them. Get yourself a Daemonbite adapter, cheap, easy, and responsive. Hey guys, welcome back to the channel. My name is Nick, and today we're going to be building a Daemonbite adapter for MiSTer FPGA so you can use your favorite OEM Genesis controller for that old school nostalgic feel. Daemonbite adapters are great because you can build them for a reasonable price, and they work great with MiSTer with super low latency, around a millisecond. You do need some soldering skills though to be able to build these, but if you follow this guide, you'll be up and running in no time. I'll also be releasing guides for NES, SNES, N64, and Saturn adapters soon, so make sure you subscribe and turn on notifications so you know when those videos go live. I've also designed and 3D printed my own adapter case for this project. Like the video if you'd be interested in using this case for one of your adapters. Alright, so let's get into it. Here you can see all of the parts that we're going to be using for this build. First, we need to use an Arduino Pro Micro for this project. In this case, I happen to have one that can be used for 3.3 volts or 5 volts. More on that later. I also chose to go with a USB-C version in this case. We're going to be using a 9-pin DB9 connector for the Genesis controller. You can usually find these on AliExpress or other electronics components websites. I chose to go with some 22 gauge wire for this project. I only had 6 colors on hand though, so a couple of colors will be used more than once. I personally recommend using heat shrink tubing on all connections whenever possible. I find it's more secure and cleaner than electrical tape. Since we 3D printed our own case and are using threaded brass inserts in this case, we're going to use 12mm M3 hex screws to fasten the case together. Next, I decided to use an M1.4 by 5mm machine screw to fasten the Arduino board securely inside the case. If you don't have access to a 3D printer to house the Arduino, you can still build this adapter. I just recommend using electrical tape or even Kapton tape to wrap everything up once you're done to make sure that you protect all the electrical components. Last but not least is the custom case I designed and 3D printed for this adapter. Don't forget to check out my printables page for the files to download if you want to print it yourself. You can also find my other adapter cases there as well, link in the description. We're going to cut 9 wire lengths of 50mm to connect the Arduino to the DB9 controller port. I chose to cut 1 length of black, 1 length of red, 2 of white, 2 of blue, 2 of green, and 1 of yellow. You can choose whatever colors you like, but all the instructions and diagrams in this video will reference this color scheme. Strip about 1/8 of an inch or 2 to 3 millimeters of insulation off both ends of each wire. There are a lot of wires for this controller adapter, so a lot of processes need to be repeated. I didn't want any steps to be skipped over, so I'm just going to speed up the video here and there as a result. We're going to tin both ends of each wire with solder, so gently grab the bare wires and twist to make sure all strands get tightly wound together. Okay, fire up the old soldering iron and lightly tin both ends of each wire with solder. Make sure the wires are coated well, but don't glob on a bunch of extra solder. The reason you don't want too much solder here is because if you do, you won't be able to fit the wires through the vias on the Arduino board very well, and also it might be more difficult to attach the wires to the controller port later. Alright, we're done tinning the last wire. Now what we need to do is start prepping the Arduino itself. You need to solder the J1 jumper. This ensures that the Arduino gets 5 volts of power from the USB port. Next, we're going to pre-fill 9 vias on the Arduino with solder. You can see which vias are being filled in the diagram on screen. I have also included another diagram which shows where the wires from the Arduino will connect to the controller port. Now that the vias are filled with solder, we're going to insert the wires into each via. Since we filled each via previously, we're going to use the tip of our soldering iron to heat the solder in the via from the rear of the board and gently push in the wire from the top side. Again, you can reference the color-coded wiring diagram on screen to see exactly where I connected each wire. As I mentioned earlier in the video, I only had 6 different colors, so there's a little bit of duplication in the wire colors here. If you follow this color scheme, just make sure you pay careful attention to my diagrams. You can use any colors that you like, but make sure that you connect them appropriately to the controller connector later. Okay, all the wires are in, so let's start prepping the controller connector. On the rear of the controller connector, there's kind of a trough that you can fill up with solder. Make sure to pre-fill each of the 9 troughs with solder. It'll make your life a lot easier later. Now cut about 9 pieces of about 1/2 inch or 10 millimeters of heat shrink tubing. We'll be using this to protect the wire connectors with the controller port. Slide 1 piece of shrink tubing over each of the wires connected to the Arduino board. You need to do this before we solder the wires to the controller port. If you don't, you're going to have to unsolder the wire connection and put the shrink tubing on and resolder. Nobody wants to do that, it's just a bunch of extra work. Alright, awesome. All the shrink tube is prepped, so now we just need to get started connecting the wires to the controller port. Follow the diagrams on screen to make sure you solder each wire from the Arduino to the correct pin on the rear side of the controller port. Notice the diagram identifies the pins as you're looking directly at the back of the controller port and not the front. Do not get the wires reversed. You should be able to heat up the solder troughs on the back of the controller port pins and insert your pre-tinned Arduino wires right in. In this tutorial, we're soldering in the wires from pin 1 to pin 9 consecutively. Again, there are a lot of wires here and potentially some similar colors, so it's best to double check every connection. It's easy to get a little bit mixed up if you're flipping the port around to access connections from all different angles. Trust me. Just a few more wires to go. Sit back and enjoy the tunes. We'll be back momentarily to install the board into our 3D printed case. Slide the shrink tube over each connection. Make sure that all the solder has cooled off first though, so that the tube doesn't deform before you get it into position. Before we drop the assembly into the case, we need to bust out our heat gun and shrink the shrink tube to make sure all the connections on the controller port are properly covered and no connections will accidentally make contact. Just make sure that when you're shrinking the shrink tube, that you don't overheat the back side of the controller port. You don't want to melt the plastic. Okay, grab the bottom half of the enclosure and insert the USB connector of the Arduino into the case cutout for the USB port. It's a snug fit, but push the Arduino board down into the case and fasten it into place with the M1.4 screw. You can put the screw into via 9 or 10 of the Arduino board. It won't damage the Arduino. Next, insert the controller port into the slot at the front of the case and drop the top side of the enclosure into place. Finally, insert the M3 hex screws into the 4 screw holes on the bottom of the case and tighten them up snug. And that's it, the adapter is finished. Now all we need to do is flash the Arduino and it'll be ready to plug into the MiSTer. Plug in your USB-C cable to the adapter and to the PC and we'll move over to the PC. Go to the Megadrive Daemonbite GitHub page to download the zip file that we'll be using to program the Arduino. Link for the GitHub site will be in the description below. Extract the zip file and open the folder you created. Open the Sega Controller USB folder and double-click on the Sega Controller USB.ini file. The Arduino IDE program will open. If you don't have it installed, a link will be in the description. Navigate to the Tools menu and go down to the Board submenu. Select the Arduino AVR boards option and then select Arduino Leonardo. Next, go to the Tools menu again and navigate to the Port submenu. From here, select your Arduino Pro Micro from the list. In my case, mine was on port number 10. Press the right arrow button in the menu bar to proceed with the upload to the Arduino. In the bottom right hand corner of the window, you should see that the data is compiling and then being uploaded to the Arduino. If everything goes to plan, you should get a Windows notification pop up that says your Arduino Leonardo device is ready in Windows. Open the Run command in Windows by pressing the Windows key plus R. Then enter the command joy.cpl. Select your Arduino Leonardo device from the Game Controllers window and choose the Properties option. You should then see a new window open with a visual display of your button presses. Press all the buttons on the controller and the D-pad to make sure that everything is working properly. If all your inputs are reading properly, the adapter is finally finished and ready to be used with your MiSTer. Alright, now that the adapter is built and functioning, let's go over the pros and the cons. First, the pros. Number 1. Components are reasonably priced. Number 2. Low latency. It's not as fast as Snack, but it's really low. Number 3. You can flash the Arduino for use with 1 or 2 controllers. Number 4. You can connect to standard MiSTer USB ports. You're not relegated to the user port like you are with Snack. Number 5. This is a big one for some people. You can navigate the MiSTer menus. You cannot do this with Snack, but you can with Daemonbite adapters. Number 6. As an added bonus, you could use this adapter on a PC if you wanted to. And now for the cons. Number 1. This is a DIY project and it does require assembly and some knowledge of soldering. Number 2. You do have to source your own parts and availability could be tricky depending on which websites you check. Number 3. It's not zero latency, this is not Snack. If you need zero latency, it's not for you, but honestly, it's so low it's not even an issue for casual players or even for mini speedrunners. Alright, that's the Genesis Daemonbite adapter for MiSTer FPGA. Use your original OEM controller for that nostalgic retro feel, but on modern hardware. As I mentioned earlier, I'll be adding new videos soon for NES, SNES, N64, and Saturn adapters. Keep an eye out for those, so get subscribed. But what do you think? Would you build a Daemonbite adapter for your MiSTer, or just use a USB controller or maybe even go wireless? Let me know in the comments below. I'm curious what your preference is. If you enjoyed this video, drop a like and don't forget to share it. It helps me out a lot. I also stream tons of retro content on YouTube and on Twitch, so stop by sometime and say hi. As always, guys, thanks for watching, and I'll catch you in the next video.